Hello, this is the Module 7 Interactive Advanced Concept presentation involving ferrofluids. So a ferrofluid is a colloidal mixture that consists of nanoparticles of a magnetic material suspended in a solvent. This solvent is often called a carrier fluid. So in our experiment we used ink toner, and that served as those tiny magnetic particles. And we suspended it in vegetable oil, our carrier fluid. So this creates our mixture, a colloidal mixture, in which we have those tiny particles in a homogeneous mixture in the oil solution. So in this mixture, the particles are able to move around freely, but when a magnet is nearby, the particles in the fluid are magnetized and are attracted to the magnet. So these tiny particles can be actually pulled out of the homogeneous colloidal mixture, and they'll form separate clumps of magnetized particles. So, if you'd have a plate with the mixture resting on the plate and you put the magnet underneath, the particles will be pulled out of the mixture and they'll form, they're separate, almost like structures, in an attempt to attract to the magnet. So while that magnet is held close to the fluid, the particles will follow the magnet around if you were to move that magnet around, and then once the magnet is pulled away, those particles demagnetize and the ferrofluid will behave like a normal fluid again. So this process for making ferrofluid was invented in the early 1960s by NASA, and the goal was to improve upon what was at the time the movement of rocket fuel in a weightless environment. So I believe at the time they were working on an efficient way to move rocket fuel to where it needed to go so they could power the rocket, and they were trying to use a ferrofluid in order to move the rocket fuel using magnetism. And then more recently, in 2019, actually, researchers were able to create a permanently magnetic ferrofluid which keeps its magnetism even after the magnet is removed. So in the experiment I conducted, I was able to get those rare earth magnets, but they were a little bit small, so I do wonder if they were strong enough. But I used my ink toner with the vegetable oil, and I poured it onto a plastic plate, and then underneath the plate I used the little magnet to kind of move the magnet around and have the fluid follow around, or the little particles in the fluid follow the magnet around. I did not see the little like spiky structures that you could see in the video that was used as a demonstration, and I think that is mostly attributed just to the strength of the magnet. But that being said, even though there was no spiky structures, I did see the particles, kind of clump up and just form larger clumps around where the magnet was, and it would move around when I moved the magnet around. So I consider that a success. Thanks, guys. That's all I got for you.